let's now add to the story about domains of functions. So we're going to look at domains of functions which have radicals. Recall that the domain is a set of all real numbers which can be used as input, which produce a real number as output. And remember that square rooting a negative produces an imaginary number. So for example, root negative 6 is I root 6. So we don't want that. So when finding domain, we actually now need to avoid square rooting a negative, but the way we're going to phrase this is that we want the contents inside a square root to be greater than or equal to 0. So to find the domain of f of x equals 3 plus root x, inside this radical is an x. So that x is what we want to be bigger than or equal to 0. So in this example, the domain is bracket 0 comma infinity parenthesis. So all numbers that start 0 and everything bigger. Now, find the domain of f of x equals 2 plus root 3x plus 12. So we want the contents inside the square root. And inside the square root was a 3x plus 12. We want that to be greater than or equal to 0. Subtract 12 on both sides. 3x is greater than or equal to negative 12. Divide by 3 on both sides. You get x is greater than or equal to negative 4. So we can take as x, or as input, any number starting at negative 4 and anything bigger than that. So the domain is bracket negative 4 comma infinity parenthesis. One comment here. We want the content inside the square root to be greater than or equal to 0. So that content inside the square root was 3x plus 12. So that's why we wrote 3x plus 12 greater than or equal to 0. You don't want to write root 3x plus 12 is greater than or equal to 0. That is missing the point here. That is missing the point that it's square rooting a negative, which produces an imaginary. So it's the stuff that's inside the radical, like this negative 6. We just wouldn't want that to happen. So we don't want 3x plus 12 to accidentally be a negative 6. So that's why the stuff that's inside the radical, just the 3x plus 12 part that we've said, we want that to be greater than or equal to 0. So don't write root 3x plus 12 is greater than or equal to 0. Okay, so let's now summarize what we have about finding domain of a function, because it has changed a little. We've added to the story. So by default, you just get all reals with now 2 exceptions. So our old exception was avoid dividing by 0. The new thing is we want the contents inside a square root to be greater than or equal to 0. So let's take a look at this more complicated example. We'll find the domain of f of x equals 1 plus root x plus 2 over x minus 3. So avoid the denominator being 0, right? So x minus 3 equals 0. We want to avoid that situation. So we solve that equation by adding 3 to both sides, get x equals 3. So we need to avoid x equaling 3. And then also there's a radical, so the content inside the radical was x plus 2, and we want that to be greater than or equal to 0. And when you subtract 2 on both sides, we want x to be greater than or equal to negative 2. So numbers greater than or equal to negative 2 are all fine, with one exception. We have to avoid the number 3. So the domain is bracket negative 2 comma 3 parenthesis union parenthesis 3 comma infinity parenthesis. Okay, we're done with that question, but just as a follow-up, sometimes people are real thrown off by this, and it's okay if we look at negative 1. So note here that negative 1 is in this first part here, right? It's a number between negative 2 and positive 3. So negative 1, I get that the number is negative, but we've said it's in the domain. So that means that it's valid as an input. So f of negative 1 is going to be defined. Well, let's see what output we get when we use input negative 1. So let's compute what f of negative 1 is. So just take what's up there at the top, plug in a negative 1 for every x. So f of negative 1 is 1 plus root negative 1 plus 2 all over negative 1 minus 3. And so you have 1 plus root 1 over negative 4. In other words, 1 plus 1 over negative 4, or 2 over negative 4, or in other words, negative 1/2. So we got a number. We got a real number. We never ended up rooting a negative. In fact, by plugging in x as negative 1, the thing that we rooted had simplified to be a 1. So we rooted the number positive 1. Okay, let's do another one. Let's find the domain of f of x equals 31 minus root 6 minus x over x squared plus 2x minus 15. Here, let's just inventory the things that we want and need to avoid. So we want the contents inside the radical to be greater than or equal to 0. So we want 6 minus x greater than or equal to 0. And we need to avoid the denominator being 0. So we avoid x squared plus 2x minus 15 equals 0. The words want and avoid are, I think, very important to include here, because the words are morally opposites of each other. Want is something you want, and avoid is something we're running away from. Yeah. So If we add x to both sides of the inequality, we'll have 6 is greater than or equal to x. For the avoid equation, if we factor the left side, x plus 5 times x minus 3 equals 0. Let's just switch around the inequality here. So we write it as x less than or equal to 6. You can do that if you want. And then over here, after applying the zero product property and so on, we'll get these two solutions, x equals -5, x equals 3. So those two values of x, namely -5 as well as +3, those are numbers that need to be avoided as inputs. Those cause problems to be the input. But also, due to the radical, we need to make sure that the input is less than or equal to +6. So the domain here is, any really negative number works. So from -infinity up to -5, but don't include -5, so parenthesis. Union, parenthesis -5 up to 3, because we got to exclude 3. Union 3 all the way up to 6, and we can't go any further than 6 because we need to ensure that x is less than or equal to 6.